Factorization of expressions reducible to difference of squares form. Let's take a look at the expression x4 plus 64. Obviously, this is not a difference of perfect squares, but let's see how we can reduce it to that form. So if we try to solve this solution, we take a look at this expression, which can be written plus 64 equal to x square whole square plus 8 whole square. Now this is, if we remember the formula, a plus b whole square, which is in fact equal to a square plus b square plus 2ab. Here we have a square and we have b square, but we don't have 2ab. If we add 2 times, what is a is x square, what is b? b is 8. Now if we add this term, we also have to subtract this in order to keep the balance. So minus 2 times x square times 8. And now by combining these three terms, we can see that this is a perfect square of a plus b whole square. So this in a in this case is x square, b is 8. So this can be written as x square plus 8 whole square minus 2 times 8, that is 16 x square. And if we simplify a bit further, this will give us x square plus 8 whole square minus 4x whole square. And we can clearly see that this expression now is in the form of difference of perfect squares. So the factors for this would be x square plus 8 minus 4x one time, and another time that would be x square plus 8 and plus 4x. So we can simplify it a bit further. This would give us x square plus 8 minus 4x, and this would give us x square plus 8 plus 4x. And if we rearrange this in descending order, this would be x square minus 4x plus 8 times x square plus 4x plus 8. Let's take a look at another question, and the next question is factorize. Example: factorize the expression x4 plus x square plus 1. We do the same thing with this expression as well. It is not a difference of perfect squares, but by completing square we can reduce it in the form of difference of perfect squares. So for solution, we write x4 plus x square plus 1, and when we collect this term x4, which is perfect square of x square, plus 1 is a perfect square, and we write this middle term at the end plus x square. And now in order to make this a perfect square, we have to add plus 2 times x square times 1. But in order to keep the balance, we also need to subtract the same thing, minus 2 times x square times 1. So up to here, this is a square plus b square plus 2ab, which by formula is equal to x square plus 1 whole square, and then this term, this is minus 2x square and then plus x square. By simplifying the last two, which are like terms and can be added, this would be x square plus 1 whole square minus 2x square plus x square will become minus x square. And you can see that this is again the difference of perfect squares. So this would become x square plus 1 whole square minus x square. Okay, this is same thing again, but x square plus 1 minus x and x square plus 1 plus x. And now rearranging, this becomes equal to x square minus x plus 1 into x square plus x plus 1. So we can see that x4 plus x square plus 1 can be reduced in these two factors, and this is a very important technique as well for the purpose of factorization of polynomials. But now the last question, which I will leave it for you guys, is example here. Factorize x8 plus x4 plus 1. Remember the highest degree term and the lowest degree term. Those are the two terms we are interested in for completing the square. So this is x4 whole square, the highest degree term, plus the lowest degree term, which is 1 square. And well, as usual, this plus x4, we are going to write it at the end. And for completing the square, we need 2 times x4 times 1. And then in order to keep the balance, we have to subtract the same thing, x4 times 1. And now this, up to this third term, this is a square plus b square plus 2ab, and this is equal to a plus b whole square. So this would be x4 plus 1 whole square minus 2x4 plus x4, and this is equal to x4 plus 1 whole square minus x4, which can be written in fact x4 plus 1 whole square minus x square whole square. This is again the difference of two perfect squares, and we can one time add, one time subtract the two terms. x4 plus 1 minus x square and x4 plus 1 plus x square one time, and this becomes x4 minus x square plus 1 into, by rearranging, x4 plus x square plus 1. And if you remember from the last question, we further factorized this from last question, and we can write it down, x4 minus x square plus 1, and the two factors for this are x square minus x plus 1 into x square plus x plus 1. So these are the factors for the expressions which can be reduced in the form of difference of two squares. I'll see you in the next video for a new technique for factorization.